Hello students, welcome to IMS GATE Academy. In today's session, you will see the topic of Thevenins theorem. But I will give all the rules in the Thevenins. Then after I will do certain number of problems. 100% you will get satisfaction. Variety of problems I am going to do them. You can understand clearly. Why this Thevenin theorem is required? For what purpose we are using? These are all more important here. But anyhow, I will put the heading of Thevenin's theorem. Thevenin's theorem. In the GATE exam, it is given much importance for this topic. Yes, someone. Devesh Reddy, Rachapalli. Okay, good evening, Devesh Reddy. Yes, what is your branch? May I know? Devesh Reddy. May I know what is your branch? Is it ECE or electrical or IN? May I know that? May I know?
Yes,
anyhow we are going to start Thevenin's theorem. Why this theorem is required? When you can apply this theorem. Yes, ECE, sir. Very good. Very happy. Same my branch only. No problem.
But
But even in the GATE or engineering service exams or even the competitive exams, this topic is given much important. Without Thevenin's theorem, we are unable to find the GATE paper. Maximum is giving theorem. Maximum you can expect questions from the Thevenins. Anyhow, from the theorems you can expect that is one question, no doubt, understand theorem. Yes.
Suppose you are given any network. Any linear network is given here. This is the linear network. It's a linear network,
it's a must.
Thereby connected one load.
Thereby connected a load. RL.
But
But
these
these
linear
networks may
contain
contain
resistors
or inductors
or
or capacitors also.
or
Or capacitors.
Any
Any one of the element will be connected in the network.
And
And what sources will be there?
There
There will be given
dependent
dependent
or
or independent
or
or
both.
both.
These
These two sources we are going to find in the problem.
If
If you are given only independent sources,
what
way?
we need
We need to find out
the
the required parameter you will see.
In
In the same way,
if
if you are given dependent source alone,
in
in that case, how to tackle the question?
in
In case dependent and independent sources are given in the problem, what way we can tackle the question? That we can discuss in today's class.
But
But here,
this
this is nothing but the load resistance.
Current
Passing through this load,
I wish to take
as
IL.
IL.
This
This
point
point I want to take
A.
A.
This
This
point
I want to take B
point.
point.
If
If
you want to measure current across RL, you can use
Thevenins
Thevenins
theorem.
Otherwise, voltage across RL
you
you want.
Voltage across RL I want.
Load voltage you want to find. Then you can use
Thevenins theorem.
What is
What is the power consumption across RL?
There
There also you can use Thevenins theorem.
So,
So any one of these parameters, if you want to find, you can use Thevenins theorem.
Sir,
The circuit which is given, but suppose you are asked to find out the current or voltage, can I apply mesh analysis or nodal analysis? 100% allowed.
But
But certain problems will be tackled very easily
if
if you apply
Thevenins
Thevenins theorem.
Certain
problems can be done easily
if
if you are
using
the
mesh
mesh analysis
or
or
nodal
nodal
analysis.
analysis.
That you
That you
have
have
to
to select only.
Sir,
Sir, I will apply any one of the method. That is your choice.
choice is yours. Whichever the
method
method
you
you
feel
feel
easy,
easy, that
you
you
can
can
apply.
apply.
Understand my point?
Anyhow, to measure voltage and current and power, you need to use the Thevenins theorem. But when the Thevenins, one circuit is, whenever the one network is given, you must draw an equivalent circuit. That equivalent circuit must have one Thevenins voltage in series to the Thevenins resistor and must be connected load also. With the connection of these three only, we can determine voltage or current or power. So what I wish to say, when the network is given, initially you need to draw Thevenins equivalent circuit. I can draw in this way. Thevenins network is, you must get one voltage source. That voltage source is nothing but the VTH. From this network, you must get the Thevenins equivalent voltage. And also, you must draw Thevenins resistance. And you must connect a load. You must connect a load. These three are more and more important. Yes. But how to find this VTH, how to find RTH is more important. VTH can also be called as a open circuit voltage also. Why it is said as a open circuit voltage? In the given network, wherever load is given, that must be open circuited. Load is to be removed initially. Wherever, and after that, what you have to do, you find out the open circuit voltage. That open circuit voltage is nothing but Thevenins voltage. What about RTH? RTH is calculated by different techniques. RTH, how we can find? Suppose you are given independent sources now. Wherever independent sources are given, that is voltage sources are given, they must be shorted at first. Independent voltage source must be shorted. And wherever the current sources are given, independent current sources are given, that must be open circuited now. And find out the resistance across AB. Resistance is removed, load is removed, resistance across AB you calculate. You will find the RTH. Understand my point now? That is the way we can get now. And sometimes RTH will also be calculated by one more way also. RTH can be calculated by Thevenins voltage by short circuit current also accepted. This also you can apply VTH by ISC. But anyhow, in the problems I will explain different ways I will apply and get the results. So now we can start the problems and stand. The first problem given like this. Find VTH and RTH. Find VTH and RTH. These two parameters are required for the given network. For the given network, NW indicates networks. The network is a resistance of 6 ohms here connected. There is one dependent source. There is one dependent source, plus, minus. This is connected with 3I. The 4 ohm resistor is connected here. This is 4 ohm resistor. This is open circuit. A, this point is a B. This is the given problem. Thereby required voltage across AB. Voltage across AB. That is the open circuit voltage. That open circuit voltage is nothing but Thevenins voltage, I said now. But that current I is given, current across this path. In this path, what current is passing is given as a I. The one more point you have to understand clearly. If any circuit is given with a dependent source and not given any independent source, there is no independent voltage source, independent current source also. In that case, directly you can put Thevenin's voltage equal to 0 directly. Catch my point. If the network does not contain any independent sources, if you have only dependent source, directly you can put VTH equal to 0. Sir, blindly I cannot put, you explain. Yes, very good, you watch. Why VTH, what now? VTH is nothing but voltage across AB. This voltage, I can call it as a VTH only now. Please watch, I will explain. This is VTH, I can say. If you wish to find the VTH, you put the polarity plus and minus. When you apply the KVL in this path, you will get VTH. This path, you must select only now. But how we can do this means, please watch. But whenever these two terminals are what now open, no current is going to flow in the network. Current I equal to how much? I ask. Anybody can say easily, I is 0 amperes only. But when this current is 0, this voltage becomes what? I is 0, 3 into 0, 0. So this dependent source becomes 0 voltage. 0 voltage indicates it is just a short circuit only. If it is short circuited, I can have only 6 ohm resistance and 4 ohm resistance only. I cannot have any voltage source. If I don't have any voltage source, how the current is going to flow in this network? Across 4 ohms, what current will flow? It doesn't flow any current. When there is no current across 4 ohms, drop across this 4 ohm becomes 0 voltage only. Directly you can say VTH is nothing but the 0 voltage. Why, sir? No current is passing. Then VTH becomes 0 voltage. So I can write directly VTH equal to 0. With explanation, I gave it. Otherwise, I will go very blindly, sir. Easily you can say, if there is a dependent source, but not given any independent source, directly VTH equal to 0 voltage only. And what about RTH? RTH we can get by different techniques only now. By connecting the what now voltage or current source across AB, you can find. By connecting voltage across AB or current source across AB, we can determine the RTH. Otherwise, we can find by using VTH by ISC also. Different techniques are there now. Now, what I wish to do, every technique I will explain here now. Suppose I selected this, but to find the RTH, what you have to do, if you got any independent source, independent voltage source is given, directly you short circuit. If there is current source, open circuit. Anyhow, we don't have any independent sources. If you have the dependent source, that must be taken as it is. That should not be touched. That should be connected as it is in the circuit only now. I will draw this network like this now. I got a resistor. Here I got a dependent source. That source is given with what? 3I. The resistor is given 6 ohms. Here I want to connect 4 ohm resistor. Here I got 4 ohm resistor. This is 4 ohms. And across VTH, I connected one current source. Different way you can do. Just by connecting 1 ampere current source, you can do the question. Sir, I will not put the current source. I will connect the voltage source, sir. Accepted. Plus minus 1 volt you put it now. Then how I can, but I want to find RTH across these two terminals. Across these two terminals, I want to get the what now? Resistance now. Voltage across this AB, I wish to take it as a VTH. Or sorry, V I can put best. It is better to put V. Any name you can put now. The current across, the resistance across AB is nothing but RTH only. Resistance across AB is the RTH. Voltage across AB divided by current across AB, that is a 1 ampere. If I know voltage, I can determine RTH. That is why our effort is only on voltage V. How we can find this V? This voltage and this node voltage is same. We don't have any other resistance in between these two terminals. This voltage, same V I can put. And I can apply nodal analysis. By using the nodal, you can determine the V. How we can apply the nodal analysis? Away from the node, I can select current direction. This current plus, this current plus, this current equal to 0. I wish to take like this now. How I can find this current? V minus 3I, V minus 3I divided by resistance, 6 ohms. Just I applied the Ohm's law only. V minus 3I by 6. Summation of all the currents equal to 0. That point is very important as per nodal. As per the what? Now, this current is nothing but what? V by 4. I can get V by 4. What about this current? 1 ampere in reverse direction. So, this current I can put minus 1 amperes. That equal to 0. We got. You find V. What is LCM here? 12 is LCM. I can take 12 as an LCM. I can get 6 2s, 2V minus 3I. What is I here? But this I is nothing but, this current is nothing but the I we know. I. The I equal to minus 1 ampere, we know very well here. But when you connected this current source, I equal to minus 1 ampere. I equal to minus 1 amperes. So, I equal to minus plus 3 I can get here now. 3 into what? 3I into 2. This is a 2 volts we are getting. This is a 3 to 6 here. 4 3s, 3V is possible here. 3V is possible. Equal to 1 I want to put. I want to simplify. 2V plus 3V is nothing but the 5V here. This is 5V. 3 into 2, 6. This is equal to 1 into 12, 12 we know. I want to find what is the V. V equal to what? 12 minus 6 divide by 5. I can take V equal to what? 6 by 5. Finally, its value will be, anybody can give? Anybody? 1.2, 5 ones, 5 twos. 1.2 voltage we got. Once we got voltage V, resistance RTH we can determine easily now. RTH equal to what I said, voltage across AB divided by current. Voltage across AB is nothing but 1.2 volts. The current passing through AB is nothing but 1. We are getting finally 1.2 ohms. So, RTH is 1.2 ohms and VTH is nothing but 0 voltage. Such a way we can tackle only dependent source is given in the problem I say. Yes, I want to give one more good question in your hand. You please try to do this question without my help. Find second problem. You please try this question. I want to give in your hand. Find VTH. Find VTH and RTH for the network given. For the network given. The network given like this. There is a battery, independent source is given here. This is given with 10 volts. Here given one 2 ohm resistor. One 3 ohm resistor also here given. This is 3 ohm resistor. Here connected with 3 ohm resistor. Here given 2 ohm. This point is given A, this point is given B. Is asking to find voltage across AB, resistance across AB required. 10 volts, 2 ohms, 3 ohms, 3 ohms and 2 ohms. Yes, correct. Anybody can find? but I want to wait for some time. Please try to give your valuable answer. I would like to wait. How to find VTH and RTH from the given problem? What you have to do here is, initially we can try for VTH. VTH is nothing but, I said already, open circuit voltage. Open circuit voltage means the voltage between these two terminals, A and B. A and B is nothing but VTH, I can say. So directly I can write VTH is nothing but VA minus VB. I can write directly. Voltage at the point of A minus voltage at the point of the B. Difference of this voltage only. But you know very well one more point. If this voltage is a VA, even this node voltage is also same VA. The voltage at B is a VB, same VB you can have here also, no doubt. If it is a 10 voltage, same 10 voltage will be maintained at this node. At this node only. The VA is nothing but voltage across these 3 ohms. Directly I can say here now. But here the voltage across 2 ohms is nothing but the VB value here. You catch my point. This voltage, whenever it is given, same current is going to flow across 2 ohms and 3 ohms. Current is same, it is not a different. Sir, why you are putting the stress on that point, sir? When the voltage, when the current is same across the 2 resistors, easily you can determine voltage by using the voltage divider formula. Current must be same to find out to apply the voltage divider formula. Even in this side, when the supply voltage at 10 voltage here, now same current is passing across 3 ohms and 2 ohms. VB can be calculated by using voltage divider formula. That way we can find only now. So initially I wish to find VA, voltage across 3 ohms, by using voltage divider formula. How I can use? Supply voltage into, you know very well, formula. 10 into 3 by 3 plus 2, 5. I can cancel 2 times. I'm getting 6 voltage here now. So voltage at the point of A is nothing but 6 volts I got directly. But here I can apply voltage divider formula once again. I will get VB value. So voltage across 2 ohms is nothing but, I can write supply voltage 10 into 2 by 2 plus 3, 5. 2 plus 3, 5 I can get now. 5, 5, 2 series cancel. I am getting the 4 voltage. Now I can get VTH directly. So VTH equal to VA minus VB. 6 minus 4 is nothing but 2 voltage is nothing but VTH. So we got voltage across AB is nothing but 2 voltage. And I wish to find resistance across AB. What way I will find, please watch. Resistance across AB I want. In a problem it is connected only independent source. How you can determine RTH? Only resistor network is given means very simple. Wherever the voltage source is given, you short circuit directly. Wherever the current source is given, open circuit. And find out the resistance across AB directly. What I said, this voltage source must be shorted. After shorting this one, A and B is to be pulled, A is to be pulled, B is to be pulled this side, A is to be pulled this side. When A and B you are pulling means what is going to happen now? The network comes in this form. A is pulled this side. In this case, 2 and 3 will come in parallel. When you are pulling these two, you will get like this now. The 2 ohms and 3 ohms will be parallel. whenever you are pulling this 10, what now, this is shorted now, that wire will go exactly at the center like this. The 2 and 3 will be in parallel possible here now. When you are pulling like this, 3 and 2 will be parallel only now. This 2 and 3 will be parallel only possible. Understand now, when you are pulling now. These two are in parallel, these two will be parallel if you are pulling. These 3 and 2 will come parallel. That's possible. This is A, this is a B. You pull A and B. This wire is nothing but when it is shorted, it comes exact at the center. It comes at the center. But these two are in parallel, these two are in parallel, finally both are in series only possible here now. I can get directly. How I can get? How I can get here now? RTH is nothing but resistance across AB. These two are in parallel. 2 into 3, 6 by 5. 3 into 2, 6 by 5 is possible. Finally, I am getting 5 is LCM, 12 is possible. 5 2's 10.54 is possible. 2.4 ohms, mostly it is possible. That is RTH, I can say. .4 ohms, yes, we are getting that point. That way we can find. Now, I want to give one more, yes, one more student. Sir, what about short circuit 10 volts wires are? That wire only comes, that's why I said now. What I wish to say, whenever you shorted this, you try to pull A and B like this now. You pull that one out. Just you take the thread and connect such a way. Whenever A and B you are pulling, this short circuit wire exactly goes to the what now? The shifting only now. A and B you are pulling back means this will be shifted to this side. This will come and will comes to this side. That wire is nothing but this wire only now. When A and B you are stretching, this wire will be shifted to the what now? Middle only exactly because of stretching only now. Catching my point now. That way it goes only now. Anyhow, 2.4 ohms it is possible now. Otherwise, how we can get this wire line? How that short circuit line we will get now? Because it goes when you pull. If you got out, you connect a what now? One thread and pull it. Exactly this point, this wire will go to the middle exactly. Understand my point? Yes, next one. And one more question I want to give in your hand. The next question. Find VTH and RTH. By using the VTH and short circuit current, okay, understood, very good, thank you. But one more question, by using the what now? RTH I will find by using the VTH by short circuit current now. VTH by short circuit is required by connecting the current source across AB is allowed, by connecting the voltage source across AB is also acceptable now. Anyhow, please watch, you can understand. All the methods I will do. Find VTH and RTH I want. Find VTH and RTH for the network given. For the network given. How that network is given, you please watch. Here connected with 40 volts. This is with 40 volts. There is 10 ohm resistor. There is one dependent source. There is a dependent source like this. The current passing through this dependent source is 0.8 I. 0.8 I have taken. One I. Small I or capital I, your wish. And here connected with, just wait, I will give. Here connected with a resistance of 6 ohms. a resistance of 6 ohms here connected. Just wait. There is a 6 ohm resistor this side, and this is AB. This point is A, this point is B, this current is given I. Yes, such a way network was given. Can you get answer for this question? I'll check the values once again. 40 volts and 10 ohms and 0.8 I and 6 ohms and current I is required. Initially you find what is VTH here. Please find VTH from the given problem. What VTH you can get from the given problem? VTH is nothing but open circuit voltage across AB, I said. Open circuit voltage across AB. That voltage you determine at first. Can you get it? It's a very simple VTH here. How simple, you please watch. Between these two terminals, we can have VTH. VTH is calculated by different techniques. By selecting this path, by selecting this path, any loop you can take it. Any loop is acceptable. By selecting any one of the loop, you need to measure VTH value. Yes, exactly correct. 40 volts, sir. Very good, excellent. So this is nothing but plus, this is a minus, this is a current. I want to select the path in this direction. When current I is 0, this value becomes 0 only. This is an open circuit again. This is open circuit. Catching my point now. Understand? If you want, you can put otherwise. Now the circuit exactly I can draw like this now. 40 volts. When the current is 0, this voltage, this also becomes 0 only. Only 10 ohms I can find. I will get here now 6 ohm resistance. This is VTH exactly. This is exactly VTH only. I0, current becomes 0. Current 0 means open circuit. Drop across 6 ohm 0, drop across 10 ohm 0 because it is an open circuit. VTH is a 40 volts. Very good. VTH 40 volts I am getting. Now I wish to find what is RTH. By different techniques you can find, I said now, one more method I will apply. Dependent and independent sources both are given here now. You can do by different techniques. By connecting the current source across AB, otherwise short circuit directly. I want to use this short circuit directly now. To use this short circuit, this voltage source, you take it as it is. I wish to select this voltage source as it is. Generally, what you will do to find out the RTH, wherever the independent sources are given, voltage source means short circuit, current source is a open circuit, I said now. But when you are applying VTH by ISC, short circuit current, in that case, you no need to remove independent sources. They must be taken as it is. So I am applying this 40 volts here as it is. This current source is 0.8 I, 0.8 I have taken now. 0.8 I. Here I got 10 ohm resistor. This is 10 ohm resistor, that value. And this VTH, this the A and B, I want to short circuit. I got 6 ohms. What I did, I short circuited. This is one more method. This way also allowed. If not required, you can apply any other method also, no problem. But this current, I wish to select as a ISC, short circuit current. But anyhow, in the problem, this current is given I. So ISC equal to I itself. Catch my point. If this current is I, current across this side is a 0.8 I, may I know the current which is passing across this 10 ohm? I plus 0.8, 1.8 I can get here now. 1.8 I am getting that current. The same current will pass in this direction, no doubt. Now I said RTH is nothing but VTH by ISC, I said here now. Just I want to apply the KVL in this direction to get ISC. How to apply KVL? I wish to apply without touching the current source, you proceed. This side KVL I will apply. But you may get a doubt, sir, why don't you take this side, sir? If you go this side, voltage across this current source also must. We don't know voltage across this source and also current also unknown. The unknowns are going to be 2. In that case, it is not better to select this loop or this mesh. Better to select this path. In this case, we can find one variable, that is nothing but I. Once you got the I or ISC, RTH you can find. The 40 volts equal to, I can note down, 40 volts equal to 40 volts equal to, when I go this side, 6 into I plus, when I go the 6 into I, when I go this side, 10 into 1.8 I can write. Now I can write 40 equal to 10 into 1.8, 18, 18 plus 6, 24I, I can get here now, 24I, I can measure. What is I? You calculate. What is I? Anybody? Any student can give what is I in this problem. Ten by 6 means 1.67 amperes it comes. 1.67 amperes we are going to get. This I can also be taken RTH equal to 18, sir. Yes, very good. RTH is not 18. 24 ohms it came. Please take it. 24 ohms. Devesh Reddy, once again you try. RTH is not 18. It is a 24 ohms, I think. Because VTH by ISC, you know. Anyhow, 1.67 amperes. That can also be taken as a ISC also. Now, I wish to apply the formula which is given here now. VTH by ISC. VTH is nothing but, we got 40 divided by what? 1.67. Now, its value you calculate. How much you are getting now? Check it. It comes 24, I think. Now, approximately 24. Approximately it comes as a 24 ohms positives. 24 ohms. That way we can get answer. Followed this question? Yes, next question I will give. One more question. You please try this question. Without my help, you please do this question. Please do it. A problem was given like this. Find VTH and RTH. Find VTH and RTH for the network given. For the network given. What network is given here? There is current source, initial work is yours. You must try at first. If you got answer, very happy. If you don't get answer, I am here to help you. 5 amperes. The resistance of 10 ohms here connected. 10 ohms here connected. The current passing to the 10 ohm is given I. This is I. Current through this is that much value. And 3I, there is one dependent source. There is one dependent source, minus and plus. Minus and plus. That voltage is given 3I. 3I. Here connected with 2 ohm resistor. This is A, this is B. I'll check the values once again here. 5 amperes and 10 ohms, current I, 3I and 2 ohms here given. Yes, you can try this question. Will you give answer for this question? Can you give solution for this question? But I am going to wait for some time. You please do this question. Your answer is required. Please try this question. I am expecting answer from your side. Okay, I will do. Please watch. But I want voltage across these two terminals. Voltage across AB I want. Voltage across AB is nothing but VTH, you know. VTH I can put. Just I can apply the KVL in this path. I can select the path in this side. I am not going to select the path in this direction. If I go this side, voltage across 5 amperes is required. I don't have an idea about the what now, voltage across this 5A. That's why I didn't select this path. This is the path is best. But what current will flow whenever these two terminals are open circuited now, the same 5 amperes is going to flow this side. I equal to 5 amperes here possible. The current of 5 amperes will pass across this 10 ohm, no doubt at all. That current is passing now. If I equal to, I will write here best. I will write here now. Separately I will write, clearly I will write. I say this current is nothing but I equal to same 5 amperes, it is possible. Once you know this current, this voltage you can find. 3 into I. 3 into I is nothing but 5. 15 volts we can get here now, this side. But this is open circuited now. No drop across this 2 ohm. When you apply KVL in this direction, voltage is to be considered. Voltage is to be considered. We are not going to take, we are taking only now, but current is 0. That is why this voltage drop is 0 only now. I want to write like this now. VTH is nothing but whenever the KVL is applied, 2 into current is 0 in this path, plus 3I. 3I is nothing but 15, plus 15 volts when I go this side. When I go down, 10 into I is nothing but 5. Finally, what I got, 15 plus 50 is nothing but 65 volts I am getting. 65 volts we got. That is Thevenin's voltage. But I want to find again what is RTH here now. In a problem we don't find any dependent source. We got only independent source. In that case, what we got, dependent source is there, independent source also, both are there here now. Both are existing. Both are existing means what you can do then now? Wherever, one more method I will just use. You can use by short circuit. By using this short circuit method, you can find RTH equal to VTH by ISC is possible. I will apply one more way also. Across AB, I wish to connect one current source. Across AB, I want to connect a 1 ampere current source. So RTH is nothing but voltage across AB divided by current across AB only now. You can select voltage or current source across these two terminals. I say I want to draw network in this way. Wherever the current source is given, open circuited now. I wish to connect here now 10 ohms this side. 10 ohms I connected here now. This current is I. There is one dependent source. I connected dependent source as it is. That is 3I. I got here 2 ohm resistor. 2 ohm resistor now. And across AB, I wish to connect one current source in this direction. Choice is yours. I will take current source or yes, use it. I will not take current source, I will put the voltage source. Yes, it is acceptable. Choice is yours only now. Understand now. But this is A. This point is to be taken B only now. So what is RTH? I said already. Voltage across these two terminals plus minus V by current 1 ampere. Then I will get RTH. Their unknown value is nothing but V. But it is nothing but a series circuit. It doesn't have any other branches. So directly you can apply KVL in this path. to measure V. To measure V. Sir, what is I, sir? This 1 ampere is in the direction of I. In the direction of I, it passes through, There's a current across these two is nothing but same I. I is nothing but 1 ampere I can use here now. What about 3I, 3 into 1 I can put, it becomes a 3 voltage only now. When I applied the KVL, V equal to, I can write V equal to, drop across 2 ohm, 2 into 1, 2. Voltage across, voltage here is plus 3 volts, plus 3. When you go this side, 1 into 10, 10 volts I can get now. Finally, I am getting 15 volts here now. The voltage is nothing but the 15 volts. By using, yes, by using this VKM, excellent explanation, sir. Thanks a lot, thanks a lot. By using this voltage, you can measure RTH. So I can say RTH is nothing but V by I, V by 1. Voltage is 15 divided by 1, it becomes a 15 ohms only possible. That much resistance is possible in this network. Did you understand or not? Please respond. Did you understand or not? Now, I want to give one more good question in your hand. You please tackle this question. You please tackle this question. I wish to give one more question. Okay, anyhow, next one I will take. Yes, problem is given like this. Find VTH. The question is given, find VTH. Is asking to find VTH. Find VTH. The problem is given here connected with, for the network given. For the network given. For the network given. For the network given here now. And the network here given is 1 ohm resistor here. There is 1 ohm resistor. And there is 1 ohm resistor here given. And 3 Vx here connected. This current source is 3 Vx here given. This is 3 Vx. 2 ohm resistor is connected this side. There is a 2 ohm resistor and 3 amperes of current is connected this side. This is 3 amperes of current. And these two terminals are given as A and B. Yes, that is the given network. Will you try this question? I will wait for some time. Anybody can give answer for this question? If you are getting very good, not getting means I will explain, no problem. 1 ohm, the voltage is also given now. Vx is given here now. Voltage across this is given Vx. This is Vx, it is given. 1 ohm and 1 ohm and 3 Vx. This is a 2 ohm, this is a 3 amperes, AB is given. Yes, exactly correct. But thereby asking only VTH. Only VTH is required. How to get VTH is very important. Anybody can get? What is Vx? Vx is nothing but voltage across this 1 ohm. Voltage across this 1 ohm is given Vx. Why that Vx is given? Here given one dependent source. That current source of the value 3 Vx is given. What is 3 Vx means? The Vx is nothing but voltage across this 1 ohm. To specify what is that Vx, it is given in the problem. Understand my point? Such a way given. Please try this. Shall I do otherwise? But I want VTH. This voltage I want to take it as a VTH. This is VTH plus minus. And also I can put this node voltage is nothing but same VTH because we don't have any resistors here now, no sources are there now. Directly this node voltage I can put as a VTH only now. I selected. My aim is to find this VTH. This node voltage I want to take it as a 1 V1 here for example. I selected this as a 1. Catch my point. When A and B terminals are open circuited, 3 amperes will flow in this direction. Then after, that current passes across what resistor? Can you say that? That 3 amperes passes through what resistor? Through what resistor that can flow? Across these 2 ohms it can flow the 3 amperes. So this current must be 3 amperes only. This current must be 3 amperes only. Same 3 amperes will flow. Sir, how I can find the VTH means very simple way. Just by applying the Ohm's law you can get answer. Once you know this V1 value, catch my point. Once you know this V1 value, current we know very well. 3 amperes equal to 3 amperes is nothing but current across 2 ohms. Current across 2 ohms is nothing but difference of this voltage by resistor. VTH minus V1 according to Ohm's law, VTH minus V1 by 2 ohms only. So what is required from this equation? V1 is required. Once you know the voltage of V1, the problem is very simple. Directly you can calculate the required value. Yes, what is given now? Hi sir. Yes, Nikhil Gaurav. Hi sir, good evening. But how to get that V1 value? By using the nodal analysis. I want to select nodal analysis. How that nodal is applicable? I can apply this current plus, this current plus, this current equal to 0. But this current is nothing but V1 by 1 plus 1, 2. I can put V1 by 2 ohms according to nodal, V1 by 2. In this direction, current is what? 3Vx. Current of 3Vx is passing this side. The direction of this current is reverse. So this current I want, this current minus 3Vx I can put directly. Minus 3Vx I can put. What about this current? This current is nothing but minus 3 amperes. Reverse. In reverse, it passes current of 3. Minus 3 I can put. That equal to 0. That equal to 0. Once we know the value of Vx, V1 I can get. Once I got the V1 value, I can determine VTH value directly now. That way we can do the question now. So, but how to get that? But how to get that Vx value, sir? Catch my point. This node voltage is nothing but V1. Because of this V1, is it going to flow same current or different currents across 1 ohm and 1 ohm? Across these two resistors? Yes. All are excellent. All are excellent questions, sir. Thank you very much, Nikhil sir. Thank you, thank you, thanks you. Yes, here I want to get the what now? Vx value now. Vx is nothing but here I can apply voltage divider formula. Why I can apply the voltage divider formula? The current is passing same across 2 resistors here now. It doesn't have any deviation. It doesn't divert across any other branches now. I can say Vx is nothing but, otherwise I can simplify at first this equation now. How we can simplify this equation? I'll write like this now. I want to write in this way. When I have taken LCM, I will get V1 minus 6Vx, 3 into 2, 6 I will get here now. 2 into V1 by 2 here, this side is a 3Vx, this side is a 3 only now. Yes, we got that now. There I want to find, this is equation number 1 I have taken. This equation I have taken 1. But the Vx is nothing but, according to voltage divider formula, Vx is nothing but V1 into resistance 1 by 1 plus 1, 2 I can write. I can write V1 by 2. That Vx I can substitute in equation 1. Substituting equation 2, in equation 1, I can write directly. Then I will get V1 minus Vx is nothing but V1 by 2, that equal to 6. I can cancel here 3 times. So what I will get now, V1 minus 3V1 is nothing but minus 2V1 I will get, that equal to 6. V1 equal to how much? Minus 3 voltage I got. V1 equal to, I got 3 voltage. By using 3 voltage, minus 3 voltage I am getting here now. Now I can get the value of VTH here now. This 3 equal to, I am substituting in this equation. I am substituting, from this I am getting now. VTH minus V1 is nothing but minus 3 minus minus plus minus minus plus 3 divided by 2. So I can write VTH plus 3 equal to 6. Then VTH is nothing but 6 minus 3. That becomes 3 voltage. Yes, we got 3 voltage. We got 3 voltage here now. Such a way we can calculate the required resistor. And one more good question I can do. But I will select the what now, one operational amplifier question now by using the Thevenins. That means that the question may be op amp, but the work what we do is nothing but network only. It is the combination of network and analog only now. Network and analog I will combine. I will do the question now here now. Shall I give? Are you ready to do this question? Yes, please watch. This is one more good question. By using Thevenins and also by using analog, I will do this question. Question I want to give like this now. One source in the gate, such a model. Find V0. I want output voltage. When op amp is, when operational amplifier is ideal only. By using Thevenins, I want to do. There is an op amp here. Here connected with a resistance of 4 ohms. 4K we can put now best. I'll use this as a 4K. This is 4K. I'm giving here now, this is 16K. This V0 I want to connect this network like this now. There is 132 voltage or 64 we can use now best. I'm using 64 volts best. This is connected with 4 volts. There is a resistance of 10K. Here connected with 10K. I connected here 5K. I connected here 10K. I connected here one more 5K. I connected here one 10K resistor. One 10K I connected. It's 10K. And here I want to connect here now. I want to connect this 4K directly. Direction I connection made now. By using the Thevenins theorem, you try to find. I'll see how many students can do this now. You try as a homework best. We can close it now. Thank you.